Hi everyone, it's Emmett from Pi My Life Up. In this video, we'll be showing you how to set up the UniFi network controller on a Raspberry Pi. Self-hosting this network server allows you to control your UniFi access points without needing to invest in a more expensive dedicated UniFi console. Please note that while you can self-host the UniFi network controller, you will lose out on access to UniFi Protect. To use UniFi Protect, you will need to buy a dedicated UniFi console or a UniFi NVR. Now before we get started with setting up the UniFi network controller on your Raspberry Pi, there's a few things you'll need to do. You will need to be running at least a Raspberry Pi 4 with a minimum of 2GB of RAM. If you can stretch your budget a little bit, we highly recommend going with a minimum of 4GB of RAM. Additionally, you will need to be running a 64-bit operating system. We highly recommend choosing Raspberry Pi OS Lite 64-bit edition. We will be personally running the UniFi network controller on a Raspberry Pi 5 running a 64-bit edition of Raspberry Pi OS Bookworm. The other thing you need to do is ensure that your Raspberry Pi has a static IP address. If you're unsure on how to do this, we have covered this in a guide that we will link below. Once you are ready to proceed, open up the terminal on your Raspberry Pi or connect to it using SSH. The first thing you'll want to do is update the package list by typing in sudo apt update and pressing enter. Once the update completes, upgrade any out-of-date packages by typing in sudo apt upgrade -y and then pressing enter. Our next step is to install the packages we require to set up and run the UniFi network controller on our Raspberry Pi. You can install these packages by typing in sudo apt install wget kel rng-tools libssl 1.1 and then open jdk-17-jre-headless -y. We have a mix of different tools that we're installing here. For example, we're installing the Java runtime as that is what is used to run the UniFi network controller. We are also installing RNG tools. We'll be using RNG tools to help generate entropy faster using onboard hardware. This helps significantly improve the startup speed of the UniFi network controller on your Raspberry Pi. Now to get our Raspberry Pi to actually use this hardware for generating random numbers, type in sudo nano /etc/default/rng-tools-debian. Now within this file, look for the line that starts with HRNG device =/dev/hwrng. Delete the hashtag in front of this line and then save and quit by pressing Ctrl+X and then Y and then enter. Once done, restart the RNG tools service by typing in sudo systemctl restart rng-tools. With that done, we will now want to install MongoDB onto our Raspberry Pi. This is the database server that the UniFi network controller relies on. For this particular guide, we'll be using version 4.4.18. While the new UniFi network controller supports newer versions than this, we do have a compatibility problem when using newer versions on the Raspberry Pi. 4.4.18 is the final version that's officially had any support for the Raspberry Pi 4 and older. While the Raspberry Pi 5 can run the newer releases, we'll be sticking with this older release to ensure compatibility for those who are running a Raspberry Pi 4. You can download this package by typing in wget https://0g.piMyLifeup.com/ah1e-uw/mongodb 4.4.18.deb --O mongodb.deb. With this line, we are using our redirect service to save you from having to type in a really long URL. This will redirect you to download the MongoDB 4.4.18 for ARM64 from the official MongoDB repository. Once downloaded, we can now install MongoDB to our Raspberry Pi by typing in sudo dpkg -i mongodb.deb and then pressing enter. We'll then next need to ensure that the MongoDB server has been enabled and started. We can start off by enabling MongoDB to start at boot by typing in sudo systemctl enable MongoDB. Once enabled, we can then start up the database server immediately by typing in sudo space systemctl space start space MongoDB. We'll next want to add the official Ubiquiti UniFi Network Controller package repository to our Raspberry Pi. This will ensure that we will always get the latest releases of the UniFi Network server. Let us start by adding a new source for the repository by typing in echo space single quote deb space open square bracket arch equals AMD64 space signed hyphen by equals sign slash user slash share slash keyrings slash ubiquiti hyphen archive hyphen keyring.gpg close square bracket space https colon symbol slash www.ui.com slash downloads slash UniFi slash debian space stable space ubiquiti single quote space pipe symbol space sudo space t space slash etc slash apt slash sources dot list dot d slash 100 hyphen ubnt hyphen unifi dot list space greater than symbol slash dev slash null and then press enter. Even though we are referencing AMD64 as the arch, it doesn't actually matter as the UniFi publishes a multi-arch package. Sometimes the UniFi team forgets to publish the new releases to the ARM64 repository. However, the AMD64 versions work perfectly fine on the Raspberry Pi. With that done, we will now need to add the GPG key for this package repository. The GPG key is basically used to verify that these packages were signed by and delivered from Ubiquiti themselves. You can download this GPG key by typing in kel space https colon symbol / dl.ui.com /unifi hyphen repo.gpg space pipe symbol space sudo space t space slash user slash share slash keyring slash ubiquiti hyphen archive hyphen keyring.gpg space greater than symbol slash dev slash null. As we added a new repository, we will need to run a package list update again by typing in sudo apt update and pressing enter. Now all we need to do to install the UniFi Network server onto our Raspberry Pi is to type in sudo apt install UniFi and then press enter. This install process can take a minute or two to complete. Once the network controller is installed to your Raspberry Pi, you will need to access its web interface to finish the setup process. If you have forgotten what your IP address is, you can get your local IP by using the hostname space hyphen capital I command within the terminal. Here you can see our IP address is 192.168.0.32. Now open up your favorite web browser and go to https / followed by your IP address, which in our case is 192.168.0.32, followed by the colon symbol and then the port 8443. As the UniFi Network controller is using a self-signed certificate, you will see an error message when accessing this page. Click the Advanced button and then click the Proceed to link. You'll now be greeted by the setup screen for the UniFi Network controller running on your Raspberry Pi. Start off by giving this server a name. In our case, we'll be calling ours Pi My Life Up UniFi Network Server. The next thing you'll want to do is select your country/region. In our case, we'll be selecting Australia. Once done, you will need to agree to the UniFi End User License Agreement and Terms of Service. If you have a backup from a previous setup of the UniFi Network server, you can restore that by clicking the link at the bottom of this page. Once you're ready to proceed, click the Next button. You will now be asked to set up or sign in to a UniFi account. If you prefer not to use the UniFi account, click the Advanced Setup process and follow those steps. In our case, we are going to log into our Ubiquiti account by typing in our email and password and then clicking the Sign In button. The UniFi Network controller will now finish setting itself up on your Raspberry Pi. This process should only take roughly a minute to complete. At this point, you have successfully set up the UniFi Network server on your Raspberry Pi. You can now begin to add any access points and configuring everything to suit your particular network needs. If you like this guide, be sure to give us a thumbs up and subscribe. Until next time, have a good one.